Oh, really? He wasn't feeling good. I heard him talking to somebody this morning about that.
My sister got it.
I took my sister Friday night, and she's sick. She has MS, and she threw up all day Saturday. I felt bad.
Still sick. She got it 2 weeks ago.
I was probably
So sick.
The nose. Oh.
Yeah. All right, thank you, George.
Was everybody else here yesterday and get the notes? Here's this too, Mason. So can you guys take out both the notes from yesterday as well as the packet?
Packet.
Because I gave you the notes for today, yesterday.
Yeah.
Seriously, I'm getting a headache already.
But remember last year when I
Give me a headache.
when I watched the film,
Did you just hand out notes and stuff?
No, you got them yesterday.
Oh, yeah.
These ones? No, not these ones.
Does everyone have the notes and the cheat sheet from yesterday?
Yeah.
So you're gonna want this side of the cheat sheet out, because we're gonna be using this a lot today. Okay? This side. Okay? All right. So today what we're going to be doing is solving exponential equations and inequalities. And then we're also going to do a little bit more with some exponential growth and decay graphs. Not graphs, but equations. So first of all, when you're solving an exponential equation, what your goal is to try to get both your bases to be the same. Are you done?
Yeah.
Okay, thank you. What you try to do when you're solving an exponential equation is get both of these to be the same. And when you do that, you can ignore these and just bring your exponents down.
For what?
Did you maybe not get from that first communication that you
God
made?
dang it, oh,
Be
shut up.
quiet? Okay, so everybody understand that if the bases are the same, you forget the bases and the exponents come down, and that is an equation we solve, okay? So when I look at this first one here, I am trying to get both 4 and 64 to the same base. When I look at the cheat sheet, okay, here's 4, and really all of these are to the first power. Okay, if you think of it like that. So here's 4 to the first, here's 4 to the third, okay? And one of our numbers was 4, and one of our numbers was 64. So when I go back here, I'm going to keep the 4 as is, okay? I'm going to leave that just as 4 to the 2n minus 1. But 64, I am going to write as 4 to the third power, because then I have both of them to the same base. So it's going to be, this is important. Oh, not so much on this one. I'll explain that later. So now that I have these both as powers of 4, it's like I can forget about these and just bring the powers down, and then I solve for the variable, okay? So I would add 1, and I would get 2n equals 4, divide by 2, n equals 2.
Is that all you do? That's the answer?
That's your answer.
Wow.
Yep. Okay, so if you look at this, you have a 2 and 32. That 2, we can't break down at all, so it's just gonna stay as 2. And if you look over here, 2 to the 5th is 32. Okay? So if I go back, I'm gonna leave the 2 as is. And what did we say 32 was? 2 to the 5th. Now, this is the part that's important. When you do this, you have to put this in parentheses and think of that x minus 2 out front, or out of parentheses, or vice versa. You could have done it like this. Yeah, you probably should do it this way. Okay, now, the 2's are gone. And you would get 6x, but here you have to multiply 5 times x minus 2 in parentheses. It's not just 5x minus 2. You have to go 5 times x minus 2 in parentheses. Okay? So now this would be 5x. I'm going to distribute this. 5 times x is 5x. 5 times 2 is 10. And then we go ahead and solve it. So I would subtract 5x to bring this over. And x equals negative 10. Okay. This one, we have 5 to the 5x, because 5 is the lowest power of 5 you can have. But how about 125? What is that? 5 to the 3rd. Good. So if I come back, this is going to be 5 to the 3rd times x plus 2. Okay, the 5's are gone, and I get 5x, but remember here, it's 3 times x plus 2 in parentheses. Remember to put the x plus 2 in parentheses. And then you're going to distribute here. 3 times x is 3x. 3 times 2 is 6. And then we would go ahead and solve. I'm going to subtract 3x. 5x minus 3x is 2x. And then I divide by 2. And x is 3. Okay. Then, if we go to this page, I think you guys would know with this one. Actually, no, we can do this one. 36 and 216. Okay. Do you see a 36 and a 216 in the same row? 6. Yeah. 36 and 216. So we're going to make the 36 6 squared, the 216 6 cubed. Okay. So 36 is 6 squared, and then that's to the 2x plus 4. 216 was 6 cubed, and that's times x plus 5. Then our 6's go away, and we're left with 2 times 2x plus 4 in parentheses equals 3 times x plus 5 in parentheses. On this one, you have to distribute both sides, so we're going to get 4x plus 8 when we distribute here. And on this side, we're going to get 3x plus 15. Then I bring my 3x over, and I get x plus 8 equals 15. Subtract 8, and x is 7. Okay. Now this next one looks a little bit different, and the only thing is, we're going to do it one little step different, but you're really just looking at what same row are 9 and 27 on? 3, right? What is 9 as a power of 3? 3 squared, right? To the 2x plus 1, or 7, sorry. 27 is 3 to what power? 3 to the third, okay? And then that is to the 6x minus 12th power, okay? Now, do you guys remember when you learned exponents back in chapter 4? How do you make something that is on the bottom go to the top? What do you have to change? To negative. If it's positive on the bottom and we switch it to the top, do you remember how you just changed the sign of the exponent? So if this is 3 squared on the bottom and we want to move it to the top, do you guys get that it would be 3 to the negative second power? And then that is to the 2x plus 7. Okay, and now here I have 3 to the third to the 6x minus 12. Now I have both of them be 3's, so these are gone. And my problem becomes negative 2 times 2x plus 7 equals 3 times 6x minus 12. And then I just distribute on both sides. This becomes negative 4x minus 14. This is 18x minus 36. Then I would bring this over the 4x by adding it. And I get negative 14 equals 22x minus 36. Then I would add 36. And this would be gone. This would be 22x equals negative 14 plus 36 is going to be a positive 22. So what is x going to equal? 1. Okay. Now again, with this one, what row are 64 and 16 both on? 4, right? 64 we can write as 4 to the third power, okay? And 16 we can write as 4 to the second. And that would be to the 3x plus 1, okay? Now what I want to do is bring that 4 to the third to the top. So do you guys get that? It would be 4 to the negative third to the x minus 2 equals 4 squared to the 3x plus 1. I have a 4 in each of them, okay? So I'd end up with negative 3 times x minus 2 equals 2 times 3x plus 1. And then I would do distributive. Negative 3 times x is negative 3x. Negative 3 times negative 2 is plus 6. 2 times 3x is 6x. 2 times 1 is 2. And then what I'm going to do is bring my x's to one side by adding 3x. And I get 6 equals 9x plus 2. And I'm going to subtract 2. And I get 4 equals 9x, divide by 9. And I'm just going to leave that as a fraction. 4 over 9 is simplified, so we can leave it like that. If you would have divided it, I believe you would get 0.44 repeating, and that would have been fine too. Okay? Do you feel like you need another one like that, or do you get it? Everybody good with that kind? Okay. So now, what was that? No, we're not. There is an assignment. That's how far we were going to go yesterday. Do you remember how we were going to do part of this yesterday? All right. So this is something that you've seen before up here. We did this yesterday. If you remember, exponential growth was 1 plus r, exponential decay was 1 minus r. And remember, exponential growth is going to grow from left to right. Decay is going to fall from left to right. Okay? Today they take that formula and they make a general exponential formula, and it's y equals ab to the x. We did this one earlier. We talked about just y equals b to the x. And the only difference here is a is what you start with. So we'll talk about like money or something like that. A would be how much money you started with, okay? B can be a decay, so like a car is depreciating, or B can be a growth problem like a savings account, okay? And then X is your time period. So what we're gonna do here is they are giving us, these we do not have to graph. We're gonna first write the equation for it, and then we're gonna solve it for something. So the first thing you wanna do when you look at this is how many bacteria cells is she starting with? And it's 7,500. So our A would be 7,500. Okay. Then it says after 4 hours, that is our X. Okay. There are 2,300 cells. Y is how much you end up with. So Y is a 23,000 cells. And then the first thing that we're going to do is we're going to try to write an equation, and to do that, we need to find what our B is. Okay, so we're going to do this just to find what B is. So what I'm going to do is put in for Y my 23,000. A is what I started with, which was 7,500. B is what I'm looking for. X is the number of hours, which they tell us to be 4. Okay? Well, I'm going to solve this by dividing by 7,500. These cross out. Now, if you guys want 23,000 divided by 7,500, you are going to get, oh, this is the wrong day.
3.07.
3.066666. Okay. I think it's okay to just 3.067, we'll say. Okay. Now, you guys, I don't think have done this before. Have you guys taken like a 4th root of something or a 7th root? Have you done that at all?
Yeah.
Yes. Okay. Perfect. So perfect. All right. So if this is b to the 4th, how you undo b to the 4th is you take the 4th root. Did you guys know how you undo b squared is taking the square root? And if you have b to the 3rd, you take the cubed root. So if this is the 4th power, we take the 4th root of each side. Now, how we do that on our calculators. Do you guys need to grab one? Or are you good? They're in this drawer if anyone wants to grab one. But where we are going to find that is under math. We are going to come down to number 5. Okay. And this one, we're doing the 4th root. So where it's flashing there is 4. And down inside there is 3.067. Now, those of you that have older calculators, does anyone have like one of the black ones? I guess I should ask this. Did you guys all get an option to put it up here? Everybody did? Okay, let me just check this time and make sure that that does it too. Okay, so on the TI, like the black ones, you would have to hit 4 first, So you would go 4, then do your math down to number 5, and then do 3.067. Does everybody understand that? Those of you that have this, you're going to type in the number 4 before you go to math. So you're going to type in a 4, then do math down to number 5, and then type in your 3.067. Everybody okay with that? All right. So now if we go back to our notes, right here, what we just found is we just found what B is. And B is 1.32, okay? What they want is that exponential function written. So we're gonna write it out. It's y equals, A is what we started with, which we're still gonna use, the 7,500. B is what is going to be to the power, so that's our 1.32. And then they want it to X hours, so this is our X. So the one we did at the beginning that they gave us, they told us what this was, but they did not tell us what B was. So we had to solve because we knew this and we knew that. Now we have this set so we could solve it for any number of hours, okay? So this is our equation. And now it says how many bacteria cells can be expected after 12 hours. So you would just do y equals 7,500 parentheses 1.32 to the 12. And when you do that, is that what you got? Did you round the 1.32? Oh, to the 12.
Oh.
Because it asked for 12 hours. So did you guys get 216,302? You didn't get that? It could be that I didn't round. So 7,500 parentheses 1.32 parentheses up arrow 12. Yeah, 209,869.
Yeah.
See, what I did is I didn't round that 1.32. I kept that decimal out, and then your answer is going to be buried. Yes.
So if I did the, you do the fourth and stuff, shouldn't I have gotten 23,000?
Yes. Or very close.
Like 2,000.
Did you go 7,500 and make sure that it the
No, just leave it alone.
1.32 to the fourth?
Is that actually everything?
I got
22,800. It's probably because we rounded the 1.32. We didn't keep it out as a decimal. So, all right, so you guys got like 209,869, and I usually round to 2 decimal places, so 0.07. And this is bacteria. Yes, probably, yeah. Just round it at 869 and not do the. All right. So now if we look at the next page. This is another one that's like that, where they give us the beginning population. So A is 1321045. By 2007, the population, so that is our Y. By 2007, our population was 1,512,986. Okay, and how many years was it from here to here? 7. So that is our x. All right. So when I do this, y is 1512986. My a is 1321045. My b is what I'm looking for, and it's to the 7. So the very first thing I would do is I would go and divide by 1321045. Now, if you don't want to be off, do you guys know how to pull down a number on a calculator going second answer? Does everybody know how to do that? So when you divide this first, I'll show you. So if you don't want your answers to be off, like what ours were kind of there, you would divide 1512986 divided by 1321045. And what we did on the last one is we rounded this to like 1.15, okay? What we can do is keep that for next time and not round this. If you kept this, if you did 1.15, it's not that it's wrong. It's just if you kept this whole number and pulled that into your problem next, you're just going to get a more accurate number. So for this, we just found that b to the 7th is 1.145. What root would I have to take this to? The 7th. So I'll show you how you could do that. Those of you that have the black calculators, you'd have to put in a 7 first, and then you would go math down to number 5, enter, and we're taking the 7th root. And then if I go down to here, did you guys all know that if you go second, enter, it will pull, oh. Maybe it did.
Pull the one from the ball.
Yeah, just
You
give
can
them the
also
last
just
two
do
ones.
one.
Where'd you find it? What's that? To the 1/7 floor, yes. Okay, so I'm going to try that again. Math 5, and then I want this to be 7, and here, do I need to go?
I'll do the second and then go up.
Second, yeah, you're right. Second, negative, we'll pull this down. And then you'll just have a more accurate number. It's not like you have to do it that way. But 1.02 basically is what our B is for this one. So B is 1.02. So our equation would be y equals, what we started with was the 1,321,045. And then our B is 1.02. And then our X is our, we're just going to put an X here. We're not going to do 7 because this is a general equation. Everybody understand that? Now down here, if they say 2013, how would I evaluate that? Just put 13 in here, okay? So we'd go 1,321,045, parentheses 1.02 to the 13th. What did you guys get when you did that?
1,708,912. What's a half person? Round up or do you round down?
I would just round down.
Leave up the decimal.
So what did you say, 1,000,000?
1,708,912.
912 exactly?
No, 0.57. Well, we just do that half.
Okay. Now, I have two last things to do. They're pretty quick though, okay? So if you have money in a savings account, there are two different types of interest you can get on your money. One is called simple interest and one is called compound interest. The one that you want to have, if at all possible, and sometimes you can get this in like CDs and that type of thing, is compound interest. And what that means is interest is compounded several times a year. If it's compounded annually, that's not a great deal. It's only going to compound one time. Semi-annually means twice a year, so that's N is 2. Quarterly is 4 times a year. Monthly, of course, is 12. Bi-monthly means every other month, so that's 6. Weekly, there's 52 weeks. Bi-weekly is 26. So the best you could ever get, which I don't even know if it's out there, would be a weekly compounded interest, okay? If you look here, this is also how like car loans, you pay interest compounded when you buy a house, when you buy a car. You don't do simple interest for something like that, which means you pay more interest. P is how much you put into your account. R is the rate as a decimal. N is with this, and I put this on your cheat sheet so you'll have that when you go to the test. And T is how long it's in the account. So we're going to go down, we're going to skip this problem and we're going to go down into number 6, okay? So it says you have $2,000 into an account, okay? That means that our P is $2,000. Then it says it pays 4%, so that would be, do you guys get it, would be 0.04. How much is in the account after 5 years, so T is 5. If it's compounded, and for A, it says bi-weekly. So on that chart, bi-weekly was 26 for N, okay? So we are going to go and just substitute what we know in for that. So A is going to equal P is 2,000, and we'd go 1 plus R is 0.04, N is 26, and it's to the N times T power, which is 26 times 5. Okay, here's the deal. There is a way I can show you that you can punch that entire thing into your calculator just all in one time. Yes, you just have to set that up, okay? But what you have to do then is when you're punching this in, you'd have to put a parenthesis before this and a parenthesis after that. And then up here, it depends on your calculator. If you have one of the newer ones, you should be able to just go 26 times 5. If you have one of the old ones, you might have to put these two in parentheses. If you want to just say, I'm not going to worry about that, I'm just going to try, I would plug these two in and evaluate it, and plug this in and evaluate it, and then type it in, okay? But I'll show you how we can do that. All right, so we would go 2,000, parentheses, 1 plus, and now we're doing that fraction, so we have to do a parenthesis. We're going to go parenthesis, 0.04, divided by 26, parenthesis. But here's the thing you can't forget. This parenthesis is closing off this. What else do I need? A second parenthesis to close off this. Then I can go up arrow, and on my calculator, I should be able to just do 26 times 5 because it stays up there. If you have a black one, you may have to do parentheses there. And when you guys hit enter, do you get $2,442.43? Are you serious? Oh.
I only have to do parentheses once.
You only did this, you only did one here.
I did parentheses 1 plus 0.04 divided by 6 parentheses. So,
And you got the same answer?
yeah. Because division first. Yeah. Pretty sure.
If you got the same answer, then you did. All right, the next question, you guys, we should be able to keep this in our calculator because the next one wants us to do it monthly. What's the only thing that would change on this if it's monthly? The 26 changes to a 12. Did you know if you go, this is what I was doing before, if you go second, enter, it brings down what you just plugged in, and you can just go to where your 26s are and change it to a 12. And then you don't have to redo the whole thing. And you're gonna notice the money doesn't change much in this. So it must need a bigger amount of money in the account, or it must need a bigger interest rate. But 4% on a savings account, I think is pretty good. So,
At 1%.
right. So really, if you look, this one was compounded 12 times a year. This one was 26 times a year. And for that amount of money, it's 26.
What does that mean?
Every other week, the interest is compounded. You gain, I think it just means that you keep gaining it. I don't really understand it, to be honest. So you get interest on your interest, is that what you said? Okay. I'm not a business teacher, so I don't get all that, but everybody good? Okay. Everybody can do those problems now?
Yeah.
All right, so let's go. Tell me what these answers were really quick. This was
242, 442.
okay, and this one was
2441.99.
okay, last page. The only way that this last page is differently, this is exactly how we started today, except instead of an equal sign, we have a greater than or less than sign. So we have an inequality. So if you look here, what powers can I have for 10 and 1,000? I don't even know, is this on that chart? It's 10, right? 10 and 10 to the third, right? So if we go back, I'm going to have 10 to the 5b plus 2 is greater than 10 to the third. And then I ignore my 10s again, just like we did at the beginning, and I get 5b plus 2 is greater than 3. Do you guys know the rules with inequality when you're solving them? There's really one rule. If you divide or multiply by a negative, you have to switch your sign. If you multiply or divide by a negative, you switch the sign. That is the only difference. So if I do this and solve it like an equation, 3 minus 2 is 1, divide by 5, is this one even any different than just doing an equation? It's not, because we didn't have to divide by a negative. If I look at this one, 625, do you know what that is as a power of 5? 5 to the 4th, right? So this is, do you guys get if I just went right to 5 to the negative 4th? Do you guys get that? 1 over 625 would be 5 to the negative 4th, because it's really 1 over 5 to the 4th. Now I can forget my 5s, and I get 3 minus 2x is greater than or equal to negative 4. And I only have the 1x, so I'm leaving that. I have to bring this over by subtracting 3, and I get negative 2x is greater than or equal to -4, yeah, Dan?
The 625 in the original information or inequality is negative, is that right?
I think this is an equal, like
Oh,
greater than or
sorry.
equal.
Sorry.
Yep, no problem. Now, I divide by -2. So what happens? When you divide by a negative, you have to switch the sign. And 7/2 is an acceptable way to leave that, but certainly if you would have wanted to divide that and change it to 3.5, that would be fine. Do you guys want to do this last one?
We're good.
You're good? Everybody's good? Okay. Your assignment kind of small. Let me see if I can make it bigger.
Fine, I have 2 cameras on my phone, and I can't focus on this one.
Jordan.
Jordan.
It's the beginning of the class. Probably should have notebook paper.
Let me have it.
I have computer paper,
I like the lines.
so perhaps you should get some.
What?
Perhaps you should get some. What do you think?
Yeah.
Laura, did you have any questions for me?
Oh, I mean,
Okay, so once you copy this down, you're good to go.
Okay,
Thanks.
thank you.
Is that class hard?
No, it's just a lot of reading. I don't think they're reading numbers.